Good morning to all, my dear students. Today I am going to discuss about computer network models. So it consists of two network reference model, one Iso-Osi reference model and another is TCPIP reference model. So in previous class I discussed about network topologies and some basic concept of computer networks. And now in this chapter I am going to discuss computer network models. So basically what do we mean by network models? So it is also known as reference model. A reference model is conceptual layout which describes how communications between devices should occur. For efficient communications, the reference model identifies the tasks involved in intercomputer communications and divides them in logical groups called layers, with each layer performing a specific function. A communication system designed in such a manner is referred to as layered architecture. So we need a reference model as it provides various advantages. So what is the advantage of network model or reference model? Number one, it permits different types of network, software and hardware to communicate with each other. Number two, it defines standards for building network component, thereby permitting multiple vendors development. Number three, layer architecture defines which functions should be performed at which layer of the model, thereby promoting the standardization of networks. Number four, layered architecture divides the overall communication function into simpler and smaller components. Thus, it helps in component development and reducing troubleshooting activities. That is why we need layer architecture. So, the main aim behind building a layer architecture is to reduce and design complexity of a computer networks. So that is why we need layer architecture, and the architecture can be defined in this way: peer to peer, layer 1, then layer 2, layer 3. So it is higher layer, and this is middle layer, and this is lower layer. So in this way we have the layer architecture of network model. One whole network process is divided into small tasks. Each small task is then assigned to a particular layer which works dedicatedly to process and task only. Every layer does only specific work. Every layer claps together all procedures, protocols and methods which it requires to execute its piece of task. All layers identify their counterparts by means of encapsulations, header and tail. So I already said about the advantage, because layering can resolve complicated tasks by breaking it into smaller and manageable pieces. Each layer can analyze and test it independently. Number three, by layering, the functionalities are carried out in logical sequential manner. These are the advantages of layer architecture. So next we come to Iso-Osi reference model. So there are two network models heavily used in computer networks. One is Iso-Osi reference model, another is TCPIP reference model. So OSI model is a standard reference model for communications between any user in a network. By the term open system, we mean a set of protocols using which a system can be communicated with any other system, irrespective of the differences in their underlying hardware and software. In 1983, International Organization for Standardization (ISO) published a document called the Basic Reference Model for Open System Interconnections, so which visualize the network protocols as a 7-layer models. So these 7-layer models these layers are from high to low: application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. So this is very important. So each layer performs its specific task, and if we see its functionalities, then we easily understand the network model Iso-Osi reference model, how it works. With a single machine, a layer of OSI model communicates with two other OSI layers. It services to the layer that is located directly above it, and while it uses the services offered by the layer that is located directly below it. For example, the data link layer provides services to the network layer while calls upon the services of physical layer. So in contrast, during communications between two machines, each layer on source machine communicates with the corresponding layer called peer layer on the destination machine using a set of protocols that are appropriate for layer. So the main principle of this Iso-Osi reference model maybe we can discuss is each layer should perform a well-defined function. The functionality of each layer should be defined keeping in mind the internationally standardized protocol. Number 3, changes made in any layer should not affect the other layer. Number 4, the numbers of layers should be more enough so that each layer associated with distinct functions. Number 5, a different layer should be made when abstraction level changes. So if we see different functions of layer, then we see application layer. This layer is responsible for providing interface to the application user. This layer encompasses protocols which directly interact with users. So application layer protocols are, some important protocols are HTTP protocols, FTP protocols, and lots of protocols there. So we'll discuss in the later what are the protocols. Now next, presentation layer. This layer defines how data in the native format remote host should be presented in native format of host. Session layer. This layer maintains sessions between a remote host. For example, once user and password authentication is done, the remote host maintains these sessions for a while and does not ask for authentication again in that time span. Next layer is transport layer. This layer is responsible for end-to-end delivery between hosts. After that, network layer comes. This layer is responsible for address assign and uniquely address host in a network. So data link layer, this layer is also known as second layer. So this layer is responsible for reading and writing data from and onto the line. Link errors are detected at this layer. Finally, physical layer, it is layer 1. This layer defines hardware cabling, wiring, power, outputs, and pulse rates. So with this layer, data is transmitted through bits So this is layers architecture of Iso-Osi reference model. So this, if we see the functions of this model, so we can briefly discuss about its functions. If we see, the 7 layers of OSI model are divided into 2 groups according to their functionalities. So this physical data link and network layer are put in one group. These 3 layers below, layer 1 physical layer, layer 2 data link layer, and layer 3 data link layer in the one group, and above 4 layers from transport layer to application layer are in another group, because they allow interoperability among different software. The functions are actually, we have already discussed. Again, I remind you from physical layer to application layer. So physical layer, this layer defines the physical and electrical characteristics of network. It acts as a conduct between computers, networking hardware, and networking software. So it handles the transfer of data in bits, either 0 and 1s, from one computer to another computer. So next, layer 2 is data link layer. So this layer is responsible for reliable delivery of data from node to node and for providing services to the network layer. So at the sender side, the data link layer divides the packets received from the network layer into manageable form known as frames. So frames is the protocol data unit of data link layer. The data frames are then transmitted sequentially to the receiver. At the receiver end, data link layer detects and corrects any errors in the transmitted data which it gives from the physical layer. So on the other function of data link layer, error control and flow control. So error control ensures that all frames have finally been delivered to the destination's machine without error and proper order, and flow control manages the sender to send frames according to the receiving capability of the recipient. So number 3 layer is network layer. This layer provides end-to-end communications and is responsible for transporting traffic between devices which are not locally attached. So data in the network layer is called packets, which in addition to data consists source and destination address. So packets are sent from node to node with the help of any two approaches, namely virtual circuit or datagrams. So on the other functions of network layer include routing, deadlock prevention, and congestion control. So network layer makes routing decisions with the help of routing algorithms to ensure the best route for the packet from source to destinations. Congestion control tries to reduce the traffic on the network, etc. Next, fourth layer is transport layer. The basic functions of the transport layer is to handle error recognition and recovery of the data packets. It provides end-to-end communications between processes which are executing on different machines. So in this layer, the protocol establishes, maintains, and terminates communications between sender process and receiver process. So, and the session layer comes into play primarily at the beginning and end of the transmission. At the beginning of the transmission, it lets the receiver know its intent to start transmission. At the end of the transmission, it determines whether or not the transmission was successful. So some services provided by the session layer are dialog control, synchronization, and token management. So finally, presentation layer. The sixth layer, the functions of this layer is to ensure that information sent from application layer of one system would be readable by the application layer of the another system. Therefore, the presentation layer concerned with the syntax and semantic of the information transmitted. Finally, application layer. This layer is the entrance point that program use to access the OSI model and utilize network resources. This layer represents the services that directly support applications. This OSI layer is closest to the end user. Application layer includes network software that directly serves the end user of the network by providing them user interface and application features such as electronic mail. So in this way we get communications with the help of network layer. Next, with the help of network Iso-Osi reference model. So next we come to TCPIP reference model. So TCPIP reference model was developed by the US Department of Defense to connect multiple networks and preserve data integrity. So TCPIP protocols may come after OSI reference, and numbers of layers in TCPIP differ from the Iso-Osi reference model. So TCPIP reference comprises 4 layers, namely link layer or network layer, next internet layer, transport layer, and application layer. So this is data link layer, this is network layer, this is transport layer, and this is application layer. So the network layer, network access layer of TCP/IP model corresponding to the combination of physical and data link layer of OSI reference model. So physical and data link layer of Iso-Osi reference model is named as link layer. Yes, this is also network layer. And the internet layer corresponds to the network layer of OSI reference model. And application layer performs the task function of session presentation and applications layer. So here application layer stands for 3 layers. So application layer defines the protocol which enable user to interact with network, for example FTP, HTTP. Next, transport layer. This layer defines how data should flow between host main protocol at the layer of transmission control protocol TCP, and this layer ensures data delivery between hosts in order and is responsible for end-to-end delivery. Internet layer. Internet protocol IP works on this layer. This layer facilitates host addressing and recognition. This layer defines routing. And link layer. This layer provides mechanism of sending and receiving actual data, links its OSI model counterpart, and this layer is independent of underlying network architecture and hardware. So finally we have get both 2 models. So the basic difference between 2 models also important. So if we see the difference between OSI model and TCPIP model, so first point comes OSI model has a 7-layer model. It is a 7-layer model, but TCPIP model is a 4-layer model. So in case of OSI model, it was unable to connect to radio and satellite network, but in case of TCPIP model, it had the ability to connect the radio and satellite network. So third point, if we see in OSI model, it support only connection oriented communications in transport layer, while both connection oriented and connectionless communication in network layer. But in case of TCPIP model, it support both connection oriented and connectionless in transport layer, while connectionless communication in network layer. So number 4 point, it clearly distinguishes services, interfaces, and protocols in case of OSI models, but in TCPIP model it does not clearly distinguish services, interfaces, and protocols. So these are some basic differences between these two models. So now I think this will cover the network model. So finally I conclude my class today. Okay, thank you for listening and viewing my class.